Welcome to my YouTube channel. So in the previous lecture, I have discussed Cramer's rule to solve system of linear equations. So by Cramer's rule, we can solve special type of system of linear equations where n unknowns and n equations are there. So generally, if there is m equations and n unknowns, that is A m cross n matrix and x n cross n matrix and B m cross 1. So then we cannot use Cramer's rule when m and n not equal to n. When m equal to n, the systems becomes square system. Square system means n equations and n unknowns. So then we called this is a square system. N equation and n, this is equation four unknowns. So then the system becomes square system. So now we in this lecture I'll discuss the system of linear equations briefly when this m not equal to n or it can be equal. So first we discuss some basics about this system of linear equation. What is linear equation? What is solution of a equation? And then we will enter to Gauss elimination method. So our main goal is Gauss elimination method. So Gauss elimination method to solve system of linear equation. Let's start. So a linear equation in unknowns x1 x2 dot dot xn is of the form a1 x1 plus a2 x2 plus dot 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 plus an xn equal to b. This is a linear equation where n unknowns. So in this equation, this ai, that is a1 a2 dot 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 an and b are all constant term. So basically these are real numbers, and this AIs are coefficients. These AIs are called coefficient of xi. So a1 is the coefficient of x1 and dot 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 an is coefficient of xn. So AIs are coefficient of xi, and this b is constant term. B is constant term in this equation. So these are basic thing of a linear equation. And what is solution? If there exists a u belongs to Rn, that is u equal to k1 k2 dot 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 kn, such that this is satisfied, that is a1 k1 plus a2 k2 plus dot 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 an kn equal to b. If this satisfied by this vector, then we say u is a solution for this linear equation, that is x1 equal to k1 dot dot xn equal to kn. This will be the solution if this satisfies this equation. So if we put a k1 in the place of x1 and in such way kn in the place of xn, and then if this equal to b, then we call this is the solution of this linear equation. So now we discuss system of linear equation. So we discuss one linear equation. So system of linear equation means there is more than one equations with some unknowns. So a system of linear equations is a list of linear equations with same unknowns. So if there is m equations with n unknowns. So each equation has the same unknown. So x1, x2, xn are the unknown in this system of linear equation. So with the same unknown, in particular a system of m linear equation, that is L1, L2, Lm. So this equation is L1, this equation is L2, this equation is Li equation, this equation is Lm. So L1, L2, Lm equations in n unknowns. N unknown means there is n unknowns, that is x1, x2, xn. These are unknowns. So the system can be put in the form. So this is first equation, a11 x1, a12 x2 a1n xn. So there are n unknowns, that is n columns, and this is first equation b1, and this is second linear equation 21 x1 plus a22 x2 a2n xn equal to b2, and the ith equation is ai1 x1 plus ai2 x2 plus plus aij xj, that is here jth column, plus ain xn equal to bi, and the mth equation is this m1 x1 m2 x2 plus mn xn. So here this aij, so here this is aij is the coefficient matrix of the unknown xj in the equation li, and here bi is the constant term in this linear equation li. So we name it 1. So whenever we call each, this is main equation, system of linear equations with m equations and n unknowns. So this system can be written as in matrix form, a x equal to b, where a is m cross n matrix, m equations, n unknowns, and x is the, that is n unknowns, so m cross 1, so it can be multiplied n in, and b becomes m into 1, that is column matrix with m element. So this is the b, and x will be x1, x2, xn column matrix, and a will be the coefficient matrix which contains a11, 12 1n. Second row will be 21, 22 2n, and similarly. So this is the main system and the explicit form. So if we open this system, this is look like. So this can this is same. So we name it 1. So whenever we talk about this system, so you have to remember the form of the system of linear equations with m linear equations and n unknowns. So let's see. So this system is called m by n system. M by n system. So where m is number of equations and n is number of unknowns. And whenever m equal to n, so this becomes square system. So there is two type system, homogeneous and non-homogeneous. So if here b is b1 b2 bm, so whenever this becomes 0 0, so this will be, whenever this is 0, the system becomes homogeneous, and whenever this bi not equal to 0 for all I equal to 1 2 m, then the system becomes non-homogeneous. So this is m by n system. Whenever this constant term, that is b matrix, will be 0 matrix, 0 column matrix, then the system is said to be homogeneous, and whenever this system is not equal to 0, so this will be not 0, that is all bi, b1, b2, bm are not equal to 0, or this system is not 0, then the system called non-homogeneous system. So now we discuss about solution. So what will be the solution for this system? So a solution of this system 1 is a list of values for the unknowns, that is x1, x2, xn, which is a solution for each of the equations in this system. So if there is a u belongs to Rn, so which is k1 k2 dot k n such that this x1 x2, that is this can be written as x1 equal to k1, x2 equal to k2, xn equal to kn. So if this satisfied each of this equation, so that is a11 k1 a22 k2 dot plus a1n kn equal to b1, and similarly others. So if this satisfies each of these equation in the system, then we call this is a solution for the system of linear equations 1. And what is the solution set for this system? So set of all solutions of this system is called solution set. Let us take an example. So given this is a system, so where x1 x2 x3 x4 are unknowns and three equations are there. So if this is L1 equation, L2 equation, L3 equation, so three equations, that is m equal to 3 and 4 unknown, that is n equal to 4. So this is 3 by 4 system. And the question is determine whether a equal to minus 8 6 1 1 and b equal to minus 10 5 1 2 are solution of the system. So we have to determine u is a solution or not for this system, b is a solution or not for this system. So how can be determined that u is a solution or not? So simply we try to satisfy each of this equation by this solution. So here u equal to minus 8 6 1 1. So if this is a solution, so it can be written as x1 x2 x3 x4 equal to this. So we put minus 8 in the place of x1, 6 in the place of x2, and 1 in the place of x3 x4 in these three equations. And if this satisfied, then we can conclude that this is the solution. If not satisfied, if any one of these three equations is not satisfied by this u, then we say that this is a not solution for the system. So from L1 we put this value x1 equal to minus 8 plus x2, that is 6, plus 4 into x3, that is 1, plus 3 into x4, that is 1. So this is minus 2 plus 7, so this is equal to 5. So here this is equal to 5. So L1 satisfied. So for L2 we put this value of x1 x2 x3 x4. So for L2, 2 into x1, that is minus 8, plus 3 into x2, that is 6, plus x3, that is 1, minus 2 into x4, that is 1. So from here we can get minus 16 plus 18 plus 1 minus 2. So from this plus 2, and from this minus 1. From this plus 2, from this minus 1. So we get 1. So L2 is satisfied. So from this we can say that L2 is satisfied. And similarly from L3, x1, that is minus 8, plus 2 into x2, that is 6, minus 5 into 1, plus 4 into 1. So from this 12 minus 8, that is 4, from this 4, and from this will minus 5 plus 1, that is minus 1. So this is 3. So this is also 3. So L3 also satisfied. So by this u, each of these equation in the system is satisfied. So therefore this is a solution. This is a solution of the system. Is it okay? So we satisfied each of this equation by this u. So from this we can conclude that this u is a solution of this system. Now here b is given minus 10 5 1 2. So this is x1 x2 x3 x4. We replace minus 10, 5, 1, 4 in the place of x1, x2, x3, x4 respectively in each of this equation, and if this satisfied, then we say this is a solution. If not satisfied, does not satisfy, then we say this is a not solution. So for the first equation L1, so x1 equal to minus 10 plus x2 that is 5 plus 4 into x3 that is 1 plus 3 into x4 that is 2. So from this minus 5 and 6, 4, 10 plus 10. So this is plus 5. So first equation is satisfied. L1 is satisfied. Okay. For L2, 2 into x1 that is minus 10 plus 3 into x2 that is 5 plus x3 that is 1 minus 2 into x4 that is 2. So from this minus 20 plus 15 plus 1 minus 4 that is minus 3. So from this we get minus 5 and minus 3 that is minus 8. So this is minus 8, but here this is given 1. So minus 8 not equal to 1. So L2 is not satisfied by V equal to this. So then we can say that this V is not a solution for this equation, and from this we can conclude this V is not a solution for this system of linear equations. So we know to be solution, this U be a solution if U satisfied each of this equation. So we find that L2 is not satisfied by this V. Therefore, V is not a solution for this system. So we don't need to check L3 is satisfied or not by this by V, because we get L2 is not satisfied. So from this we can conclude that V is not a solution for this system. So there is a theorem. Suppose that the field K is infinite, K field. So we use that U is x1 dot dot xn or k1 dot dot kn be a solution of the system. So here U belongs to Rn, and Rn we take as a field. So Rn is a field. So in general, here K is the field taken in this theorem. So if K is infinite, then any system of linear equations has a unique solution, no solution, or an infinite number of solutions. So there is three possibilities. So whenever we can discuss it by this manner: system of linear equations. So you are given system of linear equation. So three cases arises: unique solution, no solution, or an infinite number of solutions. So whenever you are given a system of linear equations, so it can be consistent, that is solution exists, or inconsistent, that is solution does not exist, that is no solution for this case. And whenever consistent, system of linear equation is consistent, means there is two possibilities: there is unique solution, so only one solution exists. If two solutions are exist, then these two are equal. So whenever consistent, so either unique solution exists or infinite number of solution exist. So three possibilities are there. So unique solution, no solution, or infinite number of solution. These three possibilities are there whenever you are given a system of linear equations. So we will discuss how to find this system, and when unique solution exists, when no solution exists, when the system become inconsistent, when system become consistent, and if consistent, when unique solution exists, infinite number of solution exist. So for today that's it. We will discuss more about system of linear equations. Thank you very much. If you like it, please subscribe my channel and share with your friends. So it will be very beneficial for the students of Triple Bhagalpur because you guys dealing with 101 this course code. So I will discuss this course through this lecture series. Follow my lectures and share with your friends. Thank you very much.